Hello, my name is Miklos Szabo, and this is my project on the Machine Learning Foundations for Product Managers course on Coursera. The project topic is building a predictive model on predicting the electrical energy output of a combined cycle power plant. The data set itself that we were given contains 9,568 observations showing sort of hourly average ambient environmental readings from sensors at the power plant. There were 5 variables in the data set, so 5 columns, namely temperature, denoted by AT, ambient pressure AP, relative humidity RH, and exhaust vacuum V. And finally, the net hourly electrical energy output, which was denoted as PE, and that was the target variable that we are trying to predict using the combination, the 4 other variables or versions of them in our model. So all variables, including the target variable, the output variable was numerical. So this is a regression type of problem. So we need to build a supervised model from a regression type. Now I've done a quick sort of exploratory data analysis comparing denoting the relationship between the target variable and the 4 individual variables. And what we can see is that between the average temperature and the variable V, they both show a sort of strong correlation, both negative correlation with the target variable. The other 2, the AP and the RH variable, also show some correlations, but slightly weaker one and positive ones. So these may come handy, and then we can check our model, but it will be reflected at the end. Now, in terms of the tool, I went with the Google AutoML tables, which was nice because it's a sort of automated. It uses automated method for running different types of models, and it automates the process of building and optimizing ML models, machine learning models. Because of its a regression problem, it can be, in terms of potential algorithms, they can be linear regression or regression trees, other types of regressions, neural networks, the KNN method, or the support vector machine. So there are different types of models which can be used in this type of situations. Moving on to splitting the data, I went with the sort of the automatic or default version provided by AutoML, which was 80% training set, 10% validation, and 10% test set. Regarding the validation strategy, the tool went with the RMSE, so the root mean squared error, as an error metric, and I was okay with that. But as you can see on the screen, that it could have been the MAE or some other error metrics too. So I've run 2 different models. So because of the correlation, or based on the correlation sort of charts I showed earlier, I tried 2 versions. So one was including all 4 variables, and the other is only including 2. So that model 1 included all 4 variables, while model 2 only included the 2 I think a P and V variable, which were more so closely or highly correlated with the target variable. And what we can see is that the RMSE is, and actually all other error metrics, including the R squared and the MAPE, they are showing better performance for model 1 than for model 2. So I went with model 1 at the end, and that was my final version, and that was chosen and deployed. Thank you.